Today we're talking about how to know when triangles are similar to each other. Similar meaning one triangle looks like an enlargement or a shrunken version of the other, like as if you put it on a computer screen and enlarged it or shrunk it, or put it in a photocopier and enlarged it or shrunk it. Remember when we were trying to establish that triangles were congruent last semester? We had these postulates that gave us enough evidence to convince ourselves that triangles were congruent. We have similar postulates that allow us to conclude that triangles are similar, and they go by similar names: SSS, SAS. Now here's a new one for similar triangles. It's AA. And these postulates mean something a little bit different. The names look the same, but they mean something a little bit different. This SSS postulate means all three pairs of corresponding, that's an important word we'll talk about in a minute, corresponding sides produce the same ratio, and that's a key word also. You should recall a ratio can be written as a fraction, so that's what we're going to be writing, is fractions, and seeing if the fractions all come out to be the same. SAS is what you would cite if you knew that two pairs of sides produced the same ratio, and the S's are for the two sides. There's an A in between them, so the angles between the sides are congruent to each other. That's what the SAS stands for. The AA simply means that you have two pairs of congruent angles. This is it. This is the only three postulates we need. They're really the only three postulates that we have to work with. There aren't any others, truly. Let's see how we can apply these to these diagrams here. The question here is, are the following pairs of triangles similar? Yes or no? To say yes, we're going to have to either come up with this kind of evidence, this kind of evidence, or this kind of evidence. Well, there's no evidence about any angles in these two triangles at all, so these two postulates are not going to help us at all. But maybe the ratios of all of the sides are equal. So let's start writing ratios from one side to the corresponding side over here. Now, how do I know which is the corresponding side to 96? Well, since 96 is the smallest of these three sides, I've got to match it up with the smallest of those three sides. That's how you do it. So 96 over 40, that is a value of exactly 2.4. Now, what about the 168? Where does that go? Be careful here. Some people like to take this triangle and just spin it as if it could fit over that one and match up the 168 with the 75. But watch out. The 75 is the largest side in this triangle over here. That must have come from the largest side in this triangle. If this triangle is a shrunken down version of this one, then the largest side in the original triangle must still be the largest side in this triangle over here. The 168 matches up with the 70. So let's find out what 168 over 70 equals, and let's find out what 180 over 75 equals. Well, it turns out they're both 2.4. So these triangles are similar. I'm going to check the similar box, not the not similar box, because all of the ratios are the same, and they're similar by SSS. I got three ratios of sides that are all the same. And now, what is the ratio of similarity of triangle 1 to triangle 2? Well, it's this value right here, 2.4. Okay, moving on to the next example. Same thing here. I'm going to match up the smallest side over here with the smallest side over there. 60 over 100 is 0.6. Let's match up the largest side with the largest side. 110 divided by 176. That is not 0.6, it's 0.625. Those ratios are not equal. I'm not even going to waste my time with the third one because I need all three of them to be equal. Since I already have two that are not, I'm just going to check not similar. This question doesn't even apply. There is no ratio of similarity if the triangles aren't similar. Let's move on to number 3. Hey, I've got a pair of congruent angles marked for me already in this diagram. That's good. How about the sides? Largest side on the left, largest side on the right. 400 over 500 is equal to 0.8. Smallest side on the left, smallest side on the right, 320 over 400 is equal to 0.8. The ratios are the same. The angles between them are congruent, so these are similar by SAS. I'm asking again now, what is the ratio of similarity? Be careful, it's not 0.8, because look at how I'm asking for the ratio of similarity. Triangle 2 to triangle 1. The order in which you write a ratio and the order in which you name a ratio is just as important as the order in which you write a fraction. We know that 400 over 500 is not the same thing as 500 over 400. When I ask for the ratio of similarity of triangle 2 to triangle 1, I have to put aside from triangle 2 over the corresponding side from triangle 1. That ratio is not 0.8, it's 1.25. This is such an easy mistake to make, just not being careful about reading the order of the ratio. You can get wrong a whole final exam question, just completely wrong, just because you're not careful about which way you're writing the ratio. Number 4. Wow, it would seem I have no evidence of anything in this diagram. But in fact, there are congruent angles in this picture. Whoa, excuse me, my camera went haywire a little bit. Give me a moment to just plug that back in for us. Camera. Here we go. Oh, more camera problems. Let's see if that will stick. All right, that should stick. There are congruent, let me refocus that for us. There are congruent things in this picture that we can know about. You remember vertical angles from last semester? They don't have to be marked for us. We know they're congruent. Unfortunately, that's all we have in this picture. We don't have any other congruent things. I know some people would like to tell me that we've got alternate interior angles that are congruent here and maybe there, but there are no parallel lines marked here. We have to have parallel lines in order to know that we've got alternate interior angles. There's just not enough information here to know that these triangles are similar to each other. If we were able to find two pairs of congruent angles, we could have said that they're similar, but we only have one pair. Let's move on to the back side. Oh, there's those parallel line marks we were looking for in the last diagram. Here's a pair of alternate interior angles that are congruent. Here's another pair of alternate interior angles that are congruent. And of course the vertical angles are congruent. But hey, I only need two pairs of congruent angles to declare that the triangles are similar. Now here's a new question. How do we name this triangle down here so that everything matches up properly with the way this triangle is named there? I called this upper triangle DMZ. There are 6 different ways to name this triangle, but there's only one way to do it right. What matches up with angle D from triangle DMZ? Well, angle D has a single mark in it. Clearly that matches up with angle A in the other triangle, so I've got to start this triangle name with A. What does angle M match up with? Oh, angle M's got a double mark in it. That matches up with J. I must continue with J. And angle Z in this triangle is the only unmarked angle, and angle Z down here is the only unmarked angle. That's the only way to name that second triangle so that it matches up with the first one. You have to be able to do this correctly, or you'll have no hope of being successful when we get to target 2. And so now what does segment MZ correspond to? Well, MZ are the second and third letters of this name, and they match up with JZ in the big triangle. Moving on. Congruent angles here and there because they're vertical angles again. But where do we get other angles? This goes way back to the early part of the second semester. Be surprised if many people could see this coming. There are no parallel lines here. Those lines don't look parallel and they're not marked parallel. But what we do have is an inscribed angle. Remember that from January and February? We've got an inscribed angle in this circle. The vertex is on the circle. And here's the arc that it's forming. That angle must be half the measure of that arc. I know it's been a long time since we talked about that, but that probably rings a bell. And guess what? This angle right here is forming the exact same arc. This angle and this angle are both inscribed in the same arc. They're both half the measure of that arc. They have to be congruent to each other. We've got our two pairs of congruent angles. Let's match up the letters carefully. Angle I is completely unmarked. That matches up with angle C. Angle X matches up with angle X, and finally angle B matches up with angle R. It's the only way to do it. So IX corresponds to CX. Moving down to number 7. Hey, parallel lines again. That gives us congruent angles here and there. We don't have alternate interior angles here. We have corresponding angles. You remember that? Corresponding. You might recognize it better if I turn the picture around this way. Here's corresponding angles. And oh, while we're at it, here's another pair of corresponding angles. So we've got two pairs of congruent angles. By the way, do you see the two triangles in this picture? I named one of them XEV. That's one triangle. And the other triangle would be this little one right here. So what angle from the little triangle matches up with X from the big triangle? Well, it's angle X, isn't it? Those are actually the same angle shared by two different triangles. All right, and then angle E matches up with angle P, and angle V matches up with angle J, so XE corresponds to XP. Okay. Finally, number 8. This one I've already marked a pair of angles congruent for you. So I gave us a head start. If we could find one other pair of congruent angles, we're done. This one can be a little bit tricky. Right? But do you see the two triangles again? I've got this little triangle here, RMU, and this big triangle here, RHA. Here is an angle that is shared by both of those triangles. Shared by two triangles. It's congruent to itself. It's one angle, but it acts like a pair. Hey, do you remember last semester when we were doing congruent triangles? How often did we see diagrams that looked like this and we said, hey, there's a side that acts like a pair of congruent sides. This angle, we're going to see this a lot. Two triangles sharing an angle. And so it acts like a pair of angles. So now we've got RMU, that's the little triangle. Okay, and now we've got to match that up to the big triangle. Well, angle R matches up with angle R. Angle M matches up clearly with angle A. And then finally, angle U is the only unmarked angle in this little triangle. That matches up with H in the large triangle there. And so RM corresponds to RA. These triangles are similar by AA. I'm going to finish these notes in a second video. I'll do all of these problems. We'll talk about those in a second video. Look for that.